The topic which is learned in every single school in the whole world, the periodic table of elements.
What is that? Why is it important?
Imagine a world where everything from the air we breathe to the stars in the sky can be explained by an arrangement of elements. This is the magic of the periodic table, a masterpiece of science and the symbol of chemistry. Dmitri Mendeleev was born in 1834 in Siberia. His family wasn't very rich but supportive of his learning. His mother worked in a glass blowing factory. However, when the factory burned down, she took Dmitri to St. Petersburg, where he enrolled in a very good school and studied under great scientists. In 1869, Mendeleev was faced with the tough task of organizing the growing amount of known elements into a logical system. Inspired by the card games in his childhood, Mendeleev decided to organize the elements into a table based on their atomic weights and grouping elements of similar properties together. But scientists in the past have already grouped the elements into a table. So what made Mendeleev so special? Well, Mendeleev grouped the 63 known elements into the table, leaving gaps for yet to be discovered elements. He predicted the properties of the missing elements with remarkable accuracy, earning him widespread recognition in the scientific community. Now that we know where it came from, let's learn about the science behind it. Everything is made out of atoms. Previously, people assumed that atoms couldn't be broken down. In fact, the word atoms comes from the Greek word atomos, which translates as uncuttable. But later, scientists realized that there are smaller subatomic particles, like electrons, which are negatively charged, protons, positively charged, and neutrons, which have no charge. Elements are only made out of one type of atom. However, molecules and compounds can be made of many atoms. In the center of the atom is the nucleus, which is like a capsule that holds the protons and the neutrons. And around the nucleus are the energy shells, which holds the electrons, each with a certain energy value and only capable of carrying a certain amount of electrons. The arrangement of electrons is known as electric configuration. The electrons will first fill the lower energy levels before moving on to the higher energy levels. So what does this have to do with the periodic table? Well, as mentioned before, the elements are organized according to their atomic number, which is the number of protons. And in most cases, the number of protons is equal to the number of electrons. On the periodic table, we can see the periods which go down vertically and the groups which go across horizontally. As we travel across the periodic table, we can see that the mass of the atom slowly increases. So hydrogen is located in group 1, period 1 of the periodic table. So it has 1 valence electron. Patty, very comfortable chair. Furthermore, you may have noticed that all the elements are classified into different categories, as indicated by the color of some elements. To learn more about the different groups of elements, check out part 2. First, let's talk about the alkali metals. The word alkali is actually derived from the Arabic language and is translated as ashes. These metals are highly reactive, a bit dangerous, and definitely something you wouldn't want to handle without proper protection. They have low melting and boiling points and are very good conductors of electricity. They're also very soft and can be cut easily with a knife. Due to their reactivity, they can't be found freely in nature, but rather in compounds. They include elements like sodium, lithium, and potassium. And here we have the alkaline earth metals, the rock stars of the elements, always there to lend a hand or an electron when things get tough. They have a shiny appearance, low density, and low melting points. They are essential for biological processes and are commonly found in nature in rocks and minerals. They include elements like magnesium, calcium, and radium. Now, let's talk about the transition metals, the largest group in the periodic table, with their flashy appearance and their magnetic properties. Did you know that some transition metals are actually necessary to keep humans alive, like zinc, chromium, and iron? They are good conductors of heat and electricity, have high melting and boiling points, and are often used as catalysts in chemical reactions. They include elements like gold, silver, and titanium. Down in the depths, we've got the lanthanides and the actinides, which are like the nuclear ninjas of the periodic table. with powers that are both inspiring and a bit terrifying. Both of the groups are found at the bottom of the periodic table, are highly reactive and prone to nuclear reactions. They have a silvery white appearance and include elements like uranium, nobelium, and mendeleevium. The other metals, the heroes of the industry and innovation. They have moderate boiling and melting points, and high conductivity and electricity and malleability. They are often used in the construction, aerospace, and electronics. They include elements like gallium, lead, and aluminium. Now, let's talk about the metalloids, the shapeshifters of chemistry, as they possess both qualities of metals and non-metals. They serve as great conductors for heat and electricity, while also showing semiconductors behavior, which is why they're often applied in modern technologies and devices, and they include elements like polonium and silicon. Next, let's have a look at the other non-metals, which, as you can probably guess by their names, are not actually metals. This group consists of mainly gases that are found in the air. They form covalent bonds with other metals and are essential components in our lives, as they play vital roles in organic chemistry. They include elements like oxygen, carbon, and sulfur. And of course, we can't forget about the halogens. They're known for their high reactivity and tendency to form salts when they react with other metals. They have very different melting and boiling points, and they can exist in various forms in room temperature, solids, liquids, and even gas. They include elements like fluorine and chlorine. And last, but certainly not least, let's have a look at the noble gases, the least reactive elements in the whole periodic table. These colorless gases generally have full valence shell of electrons, hence they're less likely to be found in compounds. They also have low melting and boiling points. They include elements like helium, argon, and neon. And there you have it, the science and history behind the periodic table of elements, where each element has its own unique features and a vital role they play in our lives. That was Ruslana Science. Until next time. I was supposed to stop. And last but certainly not least, let's have a look at the polygons. I meant to say halogens. Sorry, again.
Why is it important?
Now let's talk about the metalloids, the shapeshifters of chemistry. Can you believe that? Like, what? As they possess qualities of both metals and non-metals. Like, mind blown. Let's have a look at the noble gases.